Hello everyone, welcome to Genius Developer. Today we are going to discuss about Metaspace. What is the new feature Metaspace added in JVM in Java 8? So Metaspace is a new type of memory area or memory space added to JVM memory. It is basically used for storing class metadata in JVM. That is data about the classes that JVM loads into memory while running the application, like class name, constructor, and class definition. So metaspace replaces the permgen memory that is called permanent generation memory. Metaspace introduced in Java 8 as a new memory feature in JVM. So until Java 7, there were a total five types of JVM memory in Java. But in Java 8, they have added one more type of memory space called meta space. So basically now there are a total six types of memory areas available in JVM machine from Java 8 onwards. These are the memory types in JVM: heap area, stack area, method area, meta space area, program counter register, and native method stack. Usually native method will be replaced by stack area. So guys, here is the JVM memory structure, or we can say JVM memory architecture. So let's go to the main diagram. So here we can see in JVM memory there are two parts. Specifically, one part is heap area and another whole part is non-heap area. So in heap is especially for storing the objects. This is one part, and other parts are like method area, meta space, code, cache, thread stacks. All these are in non-heap area. This is another diagram to understand JVM memory more with more clarity. So JVM memory actually having heap area specifically for objects and non-heap area for method area, meta space, code cache, and thread stacks. Let's talk into detail, guys. So we will understand what is the JVM memory core concept, guys. Why this JVM memory required, or different types of memory, why it is required. So JVM memory is like our home or house, guys. As we keep all our home assets or data in a very organized way so that we can do all our work or actions smoothly. The house can run smoothly, and if we require anything, we can get it immediately. For example, if we need clothes, we will get from Almira. If we want some cold drinks, we will go to fridge. If we want to cook something, we will go to kitchen. Let us suppose if we had thrown or stored all our house assets or things just in one place on the floor. Although it is inside our house only, but we will not able to complete our daily tasks smoothly because they will be always interrupting our daily works or tasks or daily actions. So we will not able to run our house smoothly. That's why if we think in just practical way, that's why girls organize their home assets very smartly so they can run the house very smoothly. Yeah, of course, boys can learn this technique from the girls. So likewise, guys, JVM stores all its data and assets in a very organized way so that it can perform any task or operation very frequently and JVM can run smoothly. So here are the key features of Metaspace, which is the new memory area in JVM introduced in Java 8 guys. So first feature is it is a native memory. Metaspace is stored in native memory area. It is not part of Java heap. It is a non-heap memory area. And dynamic sizing. Metaspace can dynamically resize itself based on the application metadata requirement. The third is stored metadata. Metaspace stored class metadata like class definitions, method data, and constant pool entries. So here are the main advantages of Metaspace over permgen is permanent generation. First is reduce out of memory error. Guys, earlier it was usually keep throwing from JVM. It is more objects created in JVM. So it was using to throw uh, out of memory error. But Metaspace reduce out of memory error from JVM machine. Now no more out of memory error. This mirror error signature shown. Now there are very less memory issues with class metadata. Second is automatic memory resizing. This is the most important feature of Metaspace, guys. Metaspace automatically adjusts its size based on the application needs. Dynamically resizing of memory helps in applications that load main class or dynamically, like G2, JEF apps or frameworks. Number third is improved performance. We can say improve JVM performance, right? Metaspace improve the performance of Java applications by efficient and optimized memory uses. So Metaspace reduce the need for full garbage collection to release the unreferenced memory areas. Here are here are the some example of errors. So before in Java 7, this kind of exception was getting through, like exception in thread main out of memory error permission space. But after Java 8 plus, you will get now exception in thread main out of memory error meta space. This is the main change, guys. So here are the key summary points about meta space. So these are the features and these are the description about the all the features. So first is the replace permission. So Metaspace completely replaces the permission memory area in Java 8, like from Java 8 features. And Metaspace stores class metadata. Metaspace stores class definition, method data, annotations, and related metadata are stored here. It grows dynamically. Unlike permission, Metaspace size can grow dynamically depending on the application's need. Native memory. It is allocated in native memory, which is off heap memory, not in the Java heap. Configurable. We can control the size using JVM options like max metaspace size. So we can control the manually also JVM metaspace size. Garbage collected. Unused class metadata can be garbage collected when classes are unloaded. So here is the Java code implementation, guys. This is my Java code implementation. I will show you the step-by-step process of JVM memory structure by running this code. So we will go to the IntelliJ, guys, and we will run this complete code in IntelliJ. So I have defined this student class, guys. So student class, it will have some instance variable and some static variables and some instance method, and it will have some static methods, and it will have the main method, guys. So let's talk about all the fields of this class, how it is getting stored, and where metaspace comes into picture in JVM memory. So let's talk about the student class first. So class name is part of the class metadata, so it is stored in metaspace. Now coming to instance variable. This instance variable is part of object, so it is stored in heap area when object is created. This is also instance variable, so this field also part of object instance stored in heap area. Static variables. So I have defined these three static variables: college name, principal name, city name. All these static variables are part of class labels, so it will be stored in metaspace. So guys, we should understand all the class label data, class label variables always will go into metaspace. So now coming to the constructor, I have defined this constructor, guys. So constructor definition is stored in metaspace as part of class definition or class metadata. Now, so this is very important point to understand, guys. All the constructors are related to class. That's why it is going to store into metaspace. Now here I have defined one static method, public static void display college. So this is method definition. This is also a static method. So this is the part of class. So this will be stored into metaspace. Now I have defined one instance method, public void show student. This will show the student detail. So method definition is also part of class label. So that's why it is stored in metaspace. Now here I have defined main method where the execution will be started. So main method also it is a static method, guys. So this is also part of direct class associated with directly class. Then it is also going to stored in metaspace area. And now here we are going to create the object of student class. Student S1 equal to new student. So guys, student will have student name and roll number. So when we are creating the object of student class, so there are two parts in this object creation, guys. This is very important line of Java code. We should understand very carefully this line. So there are two parts while creating this student object. This is one part is left side of the equal operator, and another second part is the right side of the equal operator. So left side, guys, student S1. This is just a reference variable, and this reference variable is getting defined into are getting declared into this main method. And if we are declaring any variable into any method, in that case it is called a local variable. So now student S1 reference variable, it is a local variable, guys. But here right side, this this is the most important things in Java, new student. So this is mainly you creating the object of student class using new keyword, and all the this object data will be going to store always into heap area only. It will go always into heap area. But here this reference variable of student S1, because this is a local variable of main method, that's why this object reference S1 will be stored into stack area. all the local variables always store into stack area, guys. So I hope this point is clear. This was the main points of Metaspace and JVM memory allocation, guys. So I would, and here this is calling this method. So it will show the college details, and we are calling student dot show student. So it will show the student details. Usually, the class level metadata for student field methods by code is stored into Metaspace area. Right? So let's run this class. We will see the output. What is the result is showing. So we have created here two method, guys. One for returning the college details. So after running, it is returning the college details like college name Ramaiah, college Bangalore, and principal name Amit Singh, suppose, and city name Bangalore. And here we are getting the student details like student name and roll number, etc. etc. Guys. Likewise, we can set all the details. We can set all the student details or college details. We can implement the complete application logic using this using this logic, guys. So that's all for today's topic. Hope most of the points are clear. If you guys had any doubt still in this topic, you guys please comment, and you can share your valuable inputs and feedbacks. Definitely, I will look into that and I will reply as soon as possible, guys. So thank you for watching this video so far, and have a nice day, guys.